Sonometer, Law of Tension. Title 1. To study the relation between the vibrating length of a given wire and tension for constant frequency using a sonometer. 2. To determine unknown tension. Introduction. A string fixed between two rigid supports is plucked at the center and released, sets into vibrations. The speed v of the transverse wave set along the string is given by v is equal to the square root of t upon m, where t is the tension applied to the string and m is the mass per unit length of the string or linear density of the string. If L is the length of the string vibrating in the fundamental mode, the wavelength lambda is equal to 2L. That is, L is equal to lambda upon 2. We have V is equal to N lambda, equation 2, where N is the frequency of the vibrating string. Using equations 1 and 2, we have N lambda is equal to under root T upon M. Therefore, N is equal to 1 upon lambda into under root T upon M. Here, L is equal to lambda upon 2. Therefore, N is equal to 1 upon 2L into the square root of T upon M. If N and M are constants, L is proportional to the square root of T, or L square is proportional to T. That is, L square upon T is equal to constant. This result is known as the second law of vibrating string. This law can be verified using a sonometer by paper rider method. Apparatus. The apparatus required for this experiment are a sonometer, a tuning fork, a rubber pad, a hanger, slotted weights, a meter scale, a fine V-shaped paper rider. Unknown tension. Procedure. Before starting the experiment, let us draw an observation table with columns observation number, mass added to the hanger M1 in grams, total mass M is equal to M0 plus M1 gram, tension T is equal to M into 980 in dyne, length L of the vibrating wire in centimeter with 4 subcolumns, 3 for 3 observations and 1 for the mean value of L, L square in centimeter square and T upon L square dyne per centimeter square. Let us begin the experiment. First, note the frequency of the tuning fork is equal to 512 Hz. Also note the mass of the hanger M0 is equal to 500 gram. Keep the knife edges on the sonometer with a small distance in between. Keep the sonometer wire under tension by putting a mass of 500 gram onto the hanger. The total mass M is equal to the sum of the mass of the hanger M0 and the mass added to the hanger M1. Place the paper rider on the vibrating string. Now, hold the rubber pad and strike the tuning fork slowly. Hold the stem of the fork on the sonometer and slowly move the knife edges away. At one particular distance between the knife edges, the paper rider flutters and falls off. This is the length of the vibrating wire L. It is 10.9 centimeter. Note this in the table. Repeat the procedure again and find length L of the vibrating wire 2 more times. Do not change the mass. Find the mean of L. Repeat the procedure for the same tuning fork for 4 different tensions increased in steps of 500 gram weight. Record all the observations in the observation table. Calculate tension T, L square and T upon L square and note in the respective columns. Find the mean value of T upon L square. Log calculations can be done as follows. Let us take one more observation for unknown tension T dash. The value of this unknown tension T dash can be found using graph of T versus L square. Let us plot a graph of T versus L square. Take a graph paper and mark the axes. Take L square along x-axis and T along y-axis. Write the scales so that all the observations are taken care of. Mark the origin 0, 0 and draw the graph passing through maximum of the plotted points. It is a straight line passing through the origin. Using the value of the slope and the frequency of the fork M, mass per unit length can be determined. Take 2 points, say as x1, y1 and as x2, y2 on the line. Find the slope of the line by using the formula. Slope is equal to y2 minus y1 upon x2 minus x1. Here we get the slope equal to 8,217. To determine the unknown tension T dash, draw a line parallel to y-axis through the point x is equal to 205. This line intersects the graph at a point, say P. Now, draw a line parallel to x-axis through this point to get intercept on the y-axis. This intercept gives the unknown tension T dash is equal to 16.75 into 10 raised to 5 dyne. Calculations. Formula to be used is N is equal to 1 upon 2L into the square root of T upon M. which can be written as m is equal to 1 upon 4n square into T upon L square. Therefore, 1. Value of mass per unit length using mean value of T upon L square. M is equal to 1 upon 4n square into T upon L square. M is equal to 1 upon 4 into 512 the whole square into 8124 is equal to 0.007748 gram per centimeter. 2. Value of mass per unit length using slope. M is equal to 1 upon 4n square into slope. M is equal to 1 upon 4 into 512 the square into 8217. M is equal to 0.007836 gram per centimeter. Results. 1. The graph of T versus L square is found to be a straight line. This verifies that the length of a wire vibrating in unison with a tuning fork is directly proportional to the square root of the tension in the wire. This verifies the second law of vibrating string. 2. The mass per unit length of the wire M is equal to 0.007748 gram per centimeter by calculation and 0.007836 gram per centimeter by graph. 3. The unknown tension T dash is equal to 16.67 into 10 raised to 5 dyne by calculation is equal to 16.75 into 10 raised to 5 dyne by graph. Precautions. Following precautions should be taken while performing the experiment. 1. Measure the length L of the vibrating wire directly with a scale. 2. The paper rider should be light and should be placed at the middle of the wire between the two movable bridges. 3. The tuning fork should be struck gently on the rubber pad. 4. Hold the tuning fork by its stem, not by its prongs. 5. The wire should not touch the sides of table, which increases the tension.